Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P006A, indicates a problem with the mass airflow, MAF, sensor circuit, specifically relating to its range or performance characteristics. This DTC arises when there's a discrepancy between the intake air amount measured by the MAF sensor and the amount expected as per the manifold absolute pressure MAP sensor output. The Powertrain Control Module, PCM, which manages the engine's function, flags this anomaly by storing the DTC for further analysis. The MAF sensor is located in the intake air duct just after the air cleaner and plays a vital role in determining the air-fuel mixture for optimal engine performance. If the readings from these sensors are not in sync, it can result in inefficiencies in engine operation, triggering this DTC. Understanding this DTC is crucial for ensuring the vehicle runs smoothly and efficiently, making it essential for proper troubleshooting and addressing underlying issues. The DTC P006A pertains to the performance of the mass airflow MAF sensor, which is critical for calculating the correct air-fuel mixture essential for combustion in the engine. This sensor is positioned in the intake air duct post-air cleaner, ensuring the air entering the engine is accurately measured. The MAP sensor also plays a significant role by measuring the pressure in the intake manifold, further assisting in determining the correct air mixture. When the PCM detects that the intake air volume from the MAF sensor does not align with the expected amount derived from the MAP sensor output, it recognizes this inconsistency as a performance problem. This inconsistency could potentially lead to suboptimal engine performance, including poor fuel efficiency and increased emissions, thus warranting immediate investigation and solutions. There are several potential causes for the occurrence of DTC P006A. One possibility is a damaged or malfunctioning mass airflow MAF sensor itself, which might provide incorrect readings due to wear or electrical faults. Another potential cause could be a faulty manifold absolute pressure MAP sensor. If this sensor fails, it will provide erroneous readings to the PCM about the air intake. Additionally, issues within the intake air system integrity may contribute to this DTC. This includes damaged hoses or connections, blockages or leaks that might alter the airflow entering the engine. Identifying the correct cause is crucial for rectifying the issue effectively and ensuring the engine operates within specified parameters. Symptoms associated with DTC P006A generally manifest as noticeable changes in the vehicle's performance. Most commonly, the check engine light will illuminate, indicating that there is a fault detected within the engine management system. Drivers might also experience poor engine performance, which may include sluggish acceleration, loss of power, or irregular engine idling. Furthermore, increased fuel consumption can occur due to inadequate combustion caused by incorrect air-fuel mixture readings. These symptoms not only impact the drivability of the vehicle, but can also lead to longer-term engine issues if left unaddressed, making their recognition critical for timely intervention. The first troubleshooting step involves starting the engine and stabilizing the idle at approximately 3,000 RPM without any load, which means the CVT should be set in P or N, or if it's a manual transmission, in neutral. This step is essential for replicating operating conditions under which the DTC P006A has been triggered. During this step, the engine should continue running until the radiator fan is activated, after which you would allow the engine to return to idle. Next, it's important to perform a test drive for several minutes, maintaining engine speed consistent with the previously recorded onboard snapshot parameters such as engine speed, vehicle speed, MAP sensor voltage, and TP throttle position sensor values. Throughout this process, it's crucial to monitor the Honda Diagnostic System, HDS, to check for the reappearance of DTC P006A, confirming whether the issue persists. For the second troubleshooting step, begin by performing a thorough inspection of the intake air system. This involves checking all components, such as hoses and connections, for any signs of damage, wear, or blockages that could affect airflow into the engine. Pay close attention to the positive crankcase ventilation, PCV, valve, and hose, which can also influence air management within the engine system. Additionally, inspect the air cleaner, intake air duct, and purge lines for any visible issues. If any component is found to be compromised or damaged, it may lead to the incorrect readings by the MAF or MAP sensors, thereby triggering the DTC. Ensuring normal conditions, no damages or blockages, will set a foundation for the next troubleshooting steps. The third troubleshooting step focuses on the air duct and housing related to the intake air system. In this inspection, you should check for any blockages within the intake air duct, as well as at the air cleaner housing connections. Ensure that there are no obstructions that could prevent air from flowing freely into the engine. Inspect all connections at these points to verify they are tight and secure, as loose or damaged connections can similarly contribute to fluctuation in airflow measurements. It is critical to ensure normal conditions are present. Any abnormalities found here may require immediate repairs to restore the integrity of the intake air system. The fourth step in troubleshooting involves conducting a functional inspection of the mass airflow MAF sensor. Start by stopping the engine and then use the Honda Diagnostic System, HDS, to monitor the MAF sensor's readings. Under normal conditions, the HDS should display a MAF sensor value around 0.2 grams per second, G per second. If the readings are significantly lower or higher than this expected value, it suggests that there may be a fault with the MAF sensor or the intake air temperature IAT sensor that shares the same housing. This step is critical as it isolates whether the issue stems from the MAF sensor directly. Any discrepancies noted should lead to further investigation or replacement of the sensor if found defective. The final troubleshooting step involves further testing of the MAF sensor while the engine is running. Start the engine and vary the speed between 2,000 RPM and 3,000 RPM while observing the MAF sensor readings on the Honda Diagnostic System, HDS. Under normal operating conditions, the output from the MAF sensor should change smoothly in response to the fluctuations in engine speed. If the readings remain static or do not change within expected parameters, it indicates a possible defect in the MAF sensor or its accompanying IAT sensor. Successfully confirming normal output changes at this stage will likely point to a healthy MAF sensor and clear any doubts of its performance, thus allowing for resolution of the DTC. After completing the troubleshooting steps and conducting any necessary repairs, it is crucial to verify the repair outcome. Start by clearing the stored DTC P006A from the vehicle system using the Honda Diagnostic System, HDS, to reset any fault indications. Following this, a test drive is essential to ensure that the vehicle operates normally under various conditions, replicating typical driving scenarios. This test drive helps ascertain whether the repairs have resolved the issue effectively. Monitor the system closely for any signs of a reoccurrence of the DTC. If the DTC does not reappear and the vehicle performance is restored to normal, you can confidently conclude that the repair process has been successful. To prevent the occurrence of DTC P006A in the future, implementing regular preventive maintenance for the intake air system is vital. This includes frequently inspecting the air intake components, ensuring they are free from debris and blockages that could hinder airflow to the engine. Replacing the air cleaner at recommended intervals is also crucial for maintaining optimal air quality entering the engine, thus preserving the performance of both the MAF and MAP sensors. Additionally, routinely checking the condition of hoses and tightening any loose connections can help mitigate potential air leaks or system failures. Consistent adherence to these maintenance practices will significantly enhance the longevity of your vehicle's engine performance and reduce the likelihood of DTC interference. In conclusion, understanding the roles of the mass airflow (MAF) sensor and the manifold absolute pressure (MAP) sensor is essential for diagnosing DTC P006A. The troubleshooting steps outlined provide a structured approach to identify and resolve the underlying issues efficiently. Regular maintenance of the intake system is also critical, as it ensures that air flows correctly into the engine and that both sensors function as intended. By adhering to these troubleshooting methods and maintenance practices, you not only address the immediate problem, but also safeguard your vehicle against future concerns. Staying proactive with inspections and repairs will enhance your overall driving experience while maintaining engine efficiency and performance. Please like and subscribe to the channel. See you next time.